Hello, my name is Paul Craig. I'm the Chief Developer of the EFDC Explorer Modeling System, or EEMS. Today I'd like to demonstrate the use of MPI within the EEMS framework and demonstrate the ease of use of MPI with EFDC This demonstration assumes that the full EEMS package has been installed on your computer, so all the MPI and OpenMP libraries and executables are available. Using MPI with EFDC significantly improves run times, sometimes as much as 15 times or more, depending upon the model configuration and hardware configuration. EFDC is the next generation of EFDC applications and enables much larger model domains and more complex systems to be simulated within reasonable time frames. So let me start this demonstration by first describing the model that we'll be using as a test case, which is a DSI developed demonstration model at the Chesapeake Bay. So this model that we're using has approximately 204,000 horizontal cells and 4 vertical layers. It's stretching from the ocean in the south here, using an open boundary condition, up to the north where the Susquehanna River flows into the Chesapeake. The hydrodynamics approach that we're using for the solution is a 3-time level or leapfrog solution, and we're simulating salinity as the primary constituent in this test case. So down here at the ocean boundary, or the open boundary, you can see the time series here of tidal conditions for the next couple of days, and then we're also bringing in all the major river flows into the Chesapeake. First, I want to demonstrate a single-threaded model with a single domain. The model has already been loaded, and the folder which contains the model input files can be shown at the top here. To run the EFDC model, click the Run EFDC button on the toolbar. That brings up the run control form here. Of note are the number of physical cores that are available on this machine and the number of logical processes. You can see that it's also pointing to the current executable that we're using, which is part of the installation package with EEMS. And then down below are just some options for output frequency and whether or not you want to overwrite an existing output from an existing model or not. So in this case, what we want to do is run the model with a single domain and a single thread, so it's already configured. Go ahead and overwrite the model output and just click Run. And when we do that, it brings up the EFDC model, and we're echoing the EFDC output to the screen so the user can track what is going on with the model. And then as it's setting up, it does all the model configuration for one domain or multiple domains all automatically inside of EFDC So let's go ahead and stop this run. Next, I would like to set up a MPI run using the same model domain. So let's jump back to EE here, and as mentioned, this is currently stored in this folder, or the model is in this folder here. So let's go ahead and save out a the model to a different folder, and I'm just going to overwrite the files that are in this folder here. This is 8 domain with 2 threads per domain. So I'll save that out. It'll ask if I want to overwrite. The answer is yes. Now, before we launch the model, which we could do right now, I want to go ahead and load the layout that we were looking at previously, so we can see the model results as the model is running once we start up the MPI run. So got the model ready here. So let's go ahead and run. So first off, I want to turn on domain decomposition. Do so with this checkbox here. Then I select the number of domains that I would like to use and then run automatic decomposition. I'm going to use the option here of a 1x8, so a single width across, or the width is a single domain, but the J direction is split up into 8 separate subdomains. And with that, I also then want to assign 2 cores per subdomain. So this is a total of 16 physical cores, which matches the number of physical cores on my machine. So with that configured, I can go ahead and just run EFDC Plus. It's echoing out as it's preparing the domain decomposition. And then the primary thread is echoing the processes that are going on within EFDC Plus. So now with this running, let's jump back to EE and take a look at some of the available information that's currently configured for this plan view. So first off, let's just take a look at the domain decomposition. So I turn on this layer. You can see the different domains displayed in the different shades, with the bottom, or the southernmost domain is domain 1, and the top is domain 8. Because I haven't loaded any output, this is the initial conditions that are displayed for the water surface elevation at this point. If I want to look at the initial conditions for salinity, select the salinity option. And now I would like to we'll jump back over here to the model, and we can see now that the model has been running, and we're a couple hours into the simulation. So let's take a look at what the model results are at that current time. Now we want to look at model output. To do so, we can click the refresh model output button here on the toolbar, and that goes out and reloads all the model output. It doesn't matter if you use single domain, multi-domain, it's all automatic and handled both by EFDC Plus and EE, so we can take a look at the model results. So I will click the refresh. You can see down here is what the current time is, so I'll jump to the end of the available model results at this point. So we're basically 6 hours into the simulation, and the salinity field now is at this particular time. Water surface elevation is displayed here at that particular time, and I can keep pressing refresh and it will just continue to pull down and load the latest information that is available from the model run, and then we can display model behavior as the model is running. And you could do that as many times as you'd like. Thank you for watching this EEMS video. If you'd like more information, please send an email to support@eemodelingsystem.com, or you can visit our website, eemodelingsystem.com. Thank you.